In this problem, we're given a function, p equals f of x, and we're told the meaning of the input x and the meaning of the output p, and we are to interpret the meaning of the function notation f of 280 equals 13. After I'm done explaining this, I want to show you a similar problem that's actually the same problem, but uses a slightly different use of function notation. Let's start on just doing the first problem that I posed. We are to interpret the meaning of f of 280 equals 13. So just as a refresher, the letter x is the input, and in this problem represents the amount of money spent on advertisement, and it happens to be in hundreds of dollars. So we'll use that in a minute. The output notation, however, actually has two different labels. The letter p for profit is the output, but since p is equal to f of x, that means this is also the output notation. So p is the output, and at the same time, all of the notation f of x is the output. Try not to think of the letter f as the output of the function. In fact, just the letter f by itself happens to be nothing more than the name of the function. So now when I go to interpret my problem, I'm going to line up exactly what I'm given here, p is equal to f of x, with what's given in the problem, f of 280 equals 13. Now this is written in reverse order relative to the way we define the function here. So if you let me copy this down here, except putting the 13 on the left-hand side of the equal sign, things line up in a way that it makes it more obvious whether the 280 and the 13 is an output or an input. So for example, the 280 clearly lines up with the letter x. They're both in parentheses, and x is my input and represents the amount of money spent on advertisement in hundreds of dollars. So this means $280 is spent on advertisement. Most people would not say $280. So I feel the need to interpret this into what's more commonly said in this situation. $280. Well, if you had $280, that actually means you have $28,000. All I've done here is, since the word 100 represents the number 100, and 100 has two zeros, all I did was tack on an extra couple zeros at the end of this. Or if you want, I took 280 and multiplied by 100, since I have $280. Either way, you get that $28,000 was spent on advertisement. And if you spend $28,000 on advertising, then what would happen? What would happen is p would be 13. So what does p represent? P is the profit in thousands of dollars, and the reason we can say that p is the profit is it was given as an output variable here. So p literally can be 13. It's not the name of the function. The name of the function is f. So in a minute I'm going to do a similar problem where p can't take on the value of 13 as a means to compare the different ways that function notation is used in a math class. For now, it's quite simple. P is 13, and we said P is the profit in thousands of dollars. So this doesn't mean $13 was made in profit. $13,000 is the profit. So you could either say when $28,000 is spent on advertising, the profit is, you could either say 13 and then write the words $1,000, or you could say that the profit is $13,000, and you could write it this way. Now that I've said all of that, I want to compare this problem with a very similar one. It's actually the same question and the same answer. It's just the notation that we're going to be using is a little different, where p is no longer going to be the output variable. In the next problem, p is going to be the name of the function, and you have to think about it a little differently. I want to compare this problem with the one we just did. In question 1, it was given that p was the output variable, and since p was equal to f of x was also considered to be the output variable, and f was the name of the function, and I made a comment that f could not take on values because it was nothing more than a name. So notice the difference in this problem. This time we're defining the function just to be p of x. So it turns out that in both cases, x is the input, and in both cases, x represents the amount of money spent on advertisement in hundreds of dollars. The difference, however, is that you only have one definition of the output variable here, and that would be p of x. This entire notation here, p of x, would be the output variable, and now just the letter p here would be the name of the function. So the name of the function is p, so this time p cannot take on a value. In the previous example, p was 13. In this example, that cannot happen. So the idea would be that p of x would be 13, but it would be incorrect to say that p is 13. That would be bad. So in this problem, you have to think of it as that the output variable is p of x, and p of x can be 13. So it's a subtle difference, but it's very important because teachers and textbooks can sometimes use both of these different variations on function notation in their problems. However, the explanation would be much the same. We're saying x is 280 just like before. X is 280 would have the same meaning. It would be the amount of hundreds of dollars spent on advertising. You can think of this statement as saying that p of x is 13 when x is 280. So the only way the output is 13, and notice I'm thinking of this whole thing being the output, not just the letter p. The only way the output's 13 is specifically when x is replaced with 280. However, the solution to the problem would be the same, that the profit would be $13,000. So p of x equals $13,000 of profit. So it wasn't my intent to change the problem, or even the meaning of the problem, just to show you that sometimes we define the name of the function to be f and give the output variable the same letter as what's used in the story. P is for profit. And other times we use p of x to be the output variable rather than just p. You just have to be careful when we do that, that it does not make sense to say p is 13 like we did in the first problem.